Welcome back as we begin to describe an evacuation procedure, starting with an overview of the equipment that we shall be using. The two new devices we shall be introducing are a vacuum pump and an electronic vacuum analyzer. The vacuum pump is needed in order to create a vacuum within the whole refrigerant system. This we do in order to remove air and moisture which entered the system whilst we had open tubing. The vacuum analyzer is needed so that we can monitor the degree of vacuum accurately and study or analyze the behavior of the vacuum, leading to the diagnosis of possible faults. Both these devices are expensive and they require special care. Let's discuss this issue first. Vacuum pumps depend heavily on the oil within them. A prominent sight glass provides easy visual reference. Both the quantity and the condition of the oil are important. Oil must be clear. If it is dark, then it is contaminated from previous use on a dirty system. When an excess of moisture has been through a pump, the oil tends to turn milk-like in appearance. Oil must be changed if either condition exists, and it is vitally important that you fill only to the indicated mark, with the oil type specified by the unit manufacturer. The connection to the system is made via your gauge manifold. The yellow charge hose is connected to the vacuum pump's suction valve. The gauge manifold hand control valves must both be closed, and the compressor service valves both mid-seated before the vacuum pump is started. Further, we must open any solenoid valves in the line. The pump can now be started. Next, both hand controls are opened slowly and vacuum drawing will commence. At first, you may observe visible vapor escaping the exhaust breather of the vacuum pump. You will also observe the needle drop of the compound gauge as the system falls into sub-atmospheric pressure. When enough vacuum is pooled, we close both hand control valves at the manifold and then switch off the pump in that order. This prevents the possibility of vacuum pump oil being suctioned out of the pump and into the system which you are evacuating. Let us turn our attention to the connection and operation of our vacuum analyzer. The physical connection to the system is made via this sensor lead, which incorporates a delicate transducer. The sensor lead is connected to any convenient gauge port. The service valve must first be back-seated before connecting the sensor lead. The adapter must be firmly secured. The analyzer instructions are to be followed to avoid damage. During initializing, the display reads 760. This is standard atmospheric pressure in millimeters of mercury. To obtain a reading on the analyzer, we simply crack open the service valve and observe the digital display. Readings are displayed as millimeters of mercury. To obtain readings in microns, we simply multiply the readout figure by 1000. We must always remember to back-seat the service valve after completing an analysis, or whenever the system is to be pressurized. Again, we stress that you follow the instrument manufacturer's operating instructions when using any electronic instrument. After the break, we shall demonstrate the procedure for performing a full evacuation and system analysis using the devices we have just overviewed.